Welcome back to Computer Lessons.
Look at the device you are using to watch this video. It fits in your hand or sits lightly on your desk. It is silent, cool to the touch, and millions of times more powerful than the machines used to send astronauts to the moon. We often take this speed for granted. We get annoyed if a web page takes 3 seconds to load. But to get here, to arrive at this moment of instant information, humanity had to travel a long, difficult road. It is a story of dreamers who saw a future that didn't exist yet. It is a story of wars won by mathematicians, of machines that filled entire rooms but had less memory than a musical greeting card, and of college dropouts who built empires in their garages. Today on Computer Lessons, we are going time traveling. We are going to trace the lineage of the computer from the steam-powered dreams of the 19th century to the Silicon Revolution that changed everything. Our story doesn't begin with electricity. It begins with steam and brass. In the early 1800s, a mathematician named Charles Babbage designed a machine called the Analytical engine. It was a monster of gears and levers powered by steam. Babbage never finished building it, but his design was revolutionary. It had a mill to process numbers, like a modern CPU, and a store to hold results, like modern memory. He had invented the architecture of the computer before electricity was even used for lights. But the hardware needed a soul. Enter Ada Lovelace. She was the daughter of the poet Lord Byron and a brilliant mathematician. While everyone else saw Babbage's machine as a calculator, Ada saw something more. She realized that if you could convert music or art into numbers, the machine could manipulate them. She wrote the very first algorithm intended to be processed by a machine. That is why Ada Lovelace is recognized today as history's first computer programmer. She was writing code 100 years before the first computer was even built. Fast forward to the 1930s and 40s. The world is on the brink of war. The theoretical foundation of modern computing was laid by a British genius named Alan Turing. Turing proposed a concept: a universal machine that could perform any task if you gave it the right instructions. He proved that complex problems could be broken down into simple, logical steps. Yes and no. 1 and 0. During World War II, Turing and his team at Bletchley Park built electromechanical machines to crack the Nazi Enigma code. These machines didn't just calculate numbers, they processed logic. They deciphered secret messages, saving millions of lives and shortening the war. Turing gave us the logic, but the machines were still mechanical and slow. We needed speed. We needed electricity. In 1945, the beast was born. The ENIAC. It was the first general-purpose electronic digital computer. Imagine a computer that weighs 30 tons, takes up 1,800 square feet, and consumes enough electricity to power a small town. That was ENIAC. Instead of tiny chips, it used 18,000 vacuum tubes. These looked like light bulbs. They acted as the switches for the ones and zeros. But there was a problem. Vacuum tubes were hot, fragile, and unreliable. They burned out constantly. If one tube failed, the whole calculation stopped. Programming the ENIAC didn't mean typing on a keyboard. It meant physically walking inside the computer and replugging thick black cables. It was a start, but it wasn't scalable. You couldn't put an ENIAC in your pocket. We needed a miracle invention to shrink this technology down. In 1947 at Bell Labs, 3 scientists invented a tiny device called the Transistor. This is arguably the most important invention in human history. transistor does exactly what a vacuum tube does, acts as a switch for electricity, but it is made of solid semiconductor material, usually silicon. It doesn't get hot. It doesn't burn out. And most importantly, it is tiny. This invention allowed us to move from room-sized giants to reasonable machines. But the real magic happened when engineers figured out how to print thousands, then millions, and now billions of these tiny transistors onto a single fingernail-sized piece of silicon. This is the integrated circuit, or the microchip. This is the birth of Silicon Valley. This is why computers get faster and cheaper every single year, a phenomenon we call Moore's Law. By the 1970s, computers were small enough for businesses, but normal people didn't have them at home. They were still too expensive and hard to use. Then came the hobbyists, the rebels. In 1975, the Altair 8800 was released. It was a kit you had to solder yourself. It had no screen and no keyboard, just blinking lights. But it sparked a revolution. Two young friends, Steve Jobs and Steve Wozniak, built a computer circuit board in a garage. They called it the Apple I. Around the same time, a young Bill Gates saw the future not in hardware but in software, founding Microsoft to write the code that would run on these machines. The race was on. IBM entered the market with the personal computer, or PC. Apple responded with the Macintosh. The Macintosh changed the game again in 1984 by introducing the mouse and the Graphical User Interface. No more typing obscure commands on a black screen. Now you could point and click. You had windows and folders. The computer finally became a tool for the artist, the writer, and the child. But even then, these computers were isolated. In the early 90s, Tim Berners-Lee created the World Wide Web. Suddenly, the walls came down. The PC was no longer just a calculator. It was a window to the entire world. This connectivity exploded the utility of the computer. And finally, we reached the modern era. In 2007, the computer left the desk and entered our pockets. The smartphone combined the power of supercomputers with the entire internet. In less than 100 years, we went from steam engines and vacuum tubes to carrying the entire collective knowledge of humanity in our pockets. It is a staggering pace of innovation. And it is all built on those simple principles: logic, electricity, and the switch. We have honored the history. Now, we are ready to open up the modern machine again with fresh eyes.
In the next video, we are going to look at the map of this digital city. We will explore the motherboard, the nervous system that connects the CPU, the RAM, and the GPU together. Which era of computer history fascinates you the most? The steam engines of the 1800s or the garage days of the 70s? If you found this explanation helpful, please hit the like button and subscribe to Computer Lessons. Don't forget to click the bell icon so you don't miss our next class. Thanks for watching and keep learning.